The signal is reaching from this transistor to this resistance, but in the output side there is no signal. So we have to replace these resistors because these are providing disconnection. Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this inverter series, this is our fourth video. In last video we removed the short circuit in the input stage in the voltage booster section, and we detected out of 8, 6 MOSFET were damaged. So that was the reason it was providing short circuit at the input. And today we will discuss how we can connect MOSFET, but before connecting MOSFET we have to verify this circuit, the driver stage. If we will not verify the driving stage and its driver transistors and gate charging discharging circuit, if we will not verify it properly, when we will install the MOSFET will burn immediately, or maybe it will take some time and then it will damage. We have two channels. The one channel TL494 pin number 9, and the second pin, that is pin number 10. 9 and 10, channel A and channel B. Pin number 9, it will give output to one transistor. In SMD code HY2D or sometime HY4D, or it is S8050 PNP transistor or any other number. It have C1, C2, collector number 1, collector number 2. Where is that? When we power on, I will connect the common pin to ground, multimeter to DC voltage, and I will connect to pin number 8, voltmeter at pin number 8, and we will turn on. The 12 volt will reach at pin number 8 and 11. 11 is here, pin number 8 is here. Pin number 8 input, pin 9 output. So it will drive this transistor, and we have one diode connected between base and emitter, and one 10k resistor, here 10k resistor, and one diode. Collector is connected to ground for both transistors, so it will pass this ground. 4 MOSFETs. 4 MOSFETs are in parallel. One set of 2 MOSFET here and the other 2 MOSFET here. 4 MOSFET are in parallel. Then for the second side, 2 MOSFET here, 2 MOSFET here, and we have 10 ohm resistor at the gate. Emitter to this gate we have 10 ohm resistance. So this emitter will provide signal to 4 of these MOSFETs. 2 MOSFET in parallel, it is connected to ground, so it will pass the ground to one side of the primary transformer. When the second signal will come here, these two signals will work opposite to each other. If one is high, the second will remain low. When it is low, this one is high. When it is high, so these signals will work opposite to each other. When this one high, this will low. So these signals are opposite to each other. First of all, make a cold testing. Set multimeter to ohms. Connect to the first gate of first MOSFET and second MOSFET. It is giving 20 ohm resistance. Why? Because we are measuring at this point to this point. So from this point, this resistor and this resistor in series, and if you will check from this point to emitter, it should 10 ohm. Gate to gate 20 ohm, gate to emitter 10 ohms. So it is 10 ohm. Second gate, that is here 10 ohms. It should not give continuity with the second gate, so it is giving 510 ohms like that. Third, then we have to check with the fourth. It is giving 19 ohm, 20 ohm, it is not good reading. So this one is giving 10 ohm, but this MOSFET it's giving 20 ohms. So that means this resistor is bad. It is heat up, so it is devalue. All resistors are 10 ohm and this resistor is open. This resistor is also open. We have 1, 2 and 3 resistors bad. If we will not change these resistors, now we will check the second transistor. So it is giving 1 mega ohm open circuit. It's giving here one side of resistance 0. The second side it's giving high resistance. So this MOSFET will not work. If we will install this MOSFET, it will not work. Check the second. One side the signal is available, the second side it have disconnection. So might be we have something wrong between these. Then we have to check this MOSFET. It's okay, it's okay. 10 ohm, the other gate 10 ohm, so this will give continuity with the second side, so it's okay. This is okay. Now we have to move this one, so it should give continuity here. It's giving 19 ohm, so it must be 10 ohms. It's 10 ohms. Then we have this one, it should give continuity here, so it is giving open circuit. It's giving open circuit. We have disconnection from this point to this section. These two MOSFETs will not work. If we will not clear this, if we will just replace the MOSFETs, it will make a damage. Why? Because these two will not work. This will work full because it have a good connectivity with 10 ohm resistance, but this one, this MOSFET will not switch completely because it have 20 ohm resistance. The resistance is devalued, so we have to change this resistor with 10 ohms because all gates must be switched equally. We have to verify this gate discharge components, that is diode and resistor. So most common, that is diode. So we have to check between the base and emitter. One side it will give base and emitter, and one side it will give indication of this diode. So one side it is diode, the second side emitter. Let's check this one. It's giving 0 ohm, short circuit. So maybe the diode is bad, or maybe this transistor is bad. First of all, we will check the signal. I will connect oscilloscope 1 and to the ground. It is microcontroller based inverter circuit. It will start switching, but when it will not find any output, it will disable the pin number 4 of this TL494. So TL494 will stop switching after a specific time. Now first of all, we will check the signal that is coming out to the base of these transistors. Here pin number 9 and 10. So pin number 9 is connected, so it is signal is out. Now the microcontroller interrupted and it turned off this TL494. Now we will check the second base. We will turn off the system and turn on again. The both signals 32.89 kilohertz available. So it is working at 65 kilohertz. This signal is 32.89. The second 32.89. So 32.89, 32.89, you can say it is 33. It is near to 33. So it is about 65 kilohertz. So we can say it is working at 65 kilohertz. Some inverters are working at 100 kilohertz. So if it will work at 100 kilohertz, the frequency will 50 kilohertz for one channel. For example, if we check this channel here, MOSFET of this gate, it is signal here, this signal is good here. Then we will check the second gate, good signal. Third gate, good signal. The fourth gate, good signal. It is 32.89. Then we will check signal here. So here is no signal at this gate. Input side of this resistor, there is a signal. Here is signal. The second side of the resistor, there is no signal. So that means this resistance is open. Then we will check this gate. It have no signal. Input side, the signal is reaching from this transistor to this resistance, but in the output side there is no signal. So we have to replace these resistors because these are providing disconnection. We can check continuity from the transistor. Here we have transistor. The one side it's giving continuity, one side giving continuity, but no resistance. So this resistance is open. We have to replace these resistance. Now the second issue, of this diode, we have to remove this diode because this time the signal is good. If we check just only signal, the signal is good in the output side, but the problem, it will not work properly. It will not discharge the gates properly, so these MOSFETs will damage again. First of all, we have to remove so let's check. Maybe this diode is bad, or maybe the transistor is bad. So this diode is good. We have this transistor bad. It is base to emitter short because it have short circuit between base to emitter. So the signal coming from pin number 9 is going out to the MOSFETs. It will not drive the MOSFETs properly. So we have to replace this transistor. Before installing MOSFETs, we have to replace this transistor because this time it have a short circuit. Base to collector, it is good, but base to emitter, it have short circuit. This transistor, it is good. One side it have this diode. Now as we discussed, the signal at one end of this resistance is available, the second end no signal. Signal on the gate of this MOSFET is also not available. It is a just straight line because resistance is open. So the second resistance, second MOSFET gate resistance, signal available, but the second side no signal because this resistor is open. And if we check on gate, no signal. So we have to replace the resistance. I will use 10 ohm resistance because this time I don't have SMD resistance. I will just for demonstration, I will use this 10 ohm resistance. Now I connected this resistance. We will check ohms between gate and this transistor. So it is 9.664. It is 10 ohm resistance. Before this it was open. Now we will check the signal. Now I connected this resistance, 10 ohm resistance, one side signal okay, the second side signal okay. Check on the gate of this MOSFET. The signal is available. That's good. Now we have to remove the second resistance because it is not passing the signal. One side signal available, the second side not available. So I have to replace this resistance and this resistance. Now I replaced these resistors. 10 ohm resistance here, 10 ohm on this gate, then we have second transistor here, 10 ohm. PNP transistor, it was damaged. I replaced it. I replaced these three resistors which are connected to the gate of all MOSFETs, every MOSFET. So now we will check the signal on the gates. Our first two MOSFETs were missing the gate. Our two first MOSFET that were missing gate signal, gate drive signal. I connected ground and I connected the signals. Now I have to turn on and then I will press auto set. Now both signals are displayed. Now we can see both signals are opposite to each other. Just let me explain it. If we see, we have one cycle. The signal blue, it is starting from here, then it is ending here. Then after a while the second signal will start. The second signal will work. Meanwhile the blue signal, that is low. One signal will high, the second will low. If it is yellow is high, channel A is high, channel B will low. And between the both signals there is a gap. The both channels will remain off. It is called dead time control. Channel A drive, channel B drive, and between each half cycle from channel A to channel B, channel B to channel A, there is a turn off time. It is called DTC, dead time control. It protects the MOSFETs for cross switching, to switch at the time. So it ensures that the MOSFETs are, the first MOSFET is turned off, then the second will turn on. The second will turn off, the first will turn on. So each half cycle have a dead time control between the two MOSFETs. Primary side 1 and primary side 2. Both sides will not switch together. If any IC fails to maintain the dead time control, that time the MOSFETs will damage also. So before installing any MOSFET, we have to confirm the signals. Now we will check all the signals. One signal, the second signal, then the third gate, fourth gate, fifth gate, the sixth gate, seventh gate, and gate number 8. So all 8 MOSFETs now are receiving the gate drive signal. Before installing, before replacing new MOSFETs, new IGBTs or new transistors, we must have to ensure the gate drive or the drive signal. Otherwise, if we install without checking the signal, that will damage the MOSFETs. And we have to ensure the gate discharge signal. If the gate discharge network will work properly, that time the MOSFETs will work properly. So these are the basic requirements for good function of the MOSFET. In our next session, we will install the MOSFETs here, and then we will test the output, and we will complete to our next videos. I hope so this video is informative. If it is informative, hit the like button. If you have any question, please let me know in the comment box. If you have not subscribed my channel, subscribe it. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.